MS Ramaya University of Applied Sciences.
Hi students, let us discuss on calibration of a thermocouple using standard thermometer. This experiment aims at depicting the calibration of K-type and J-type thermocouple resistance temperature detector, also known as RTD, and thermistor using a standard thermometer. Calibration is necessary for verifying the correctness of a reading as obtained by a measuring instrument. It is the comparison between a known measurement, which is a standard, and the measurement as obtained by a measuring instrument. It is carried out for a new instrument, a repaired or a modified instrument, after the lapse of a specific time period, after a specific number of hours of usage of an instrument, and in other similar scenarios. In this experiment, a thermometer having a range of 0 to 100 degrees centigrade and least count of 1 degree centigrade is used as a standard. A thermocouple is a temperature measuring device which is used to measure temperatures at high ranges, which might not be possible to measure with a thermometer. It consists of two wire legs made up of different metals joined together to form a junction. It works on the principle of Seebeck effect. When the ends of the junction are subjected to a change in the temperature, it results in the creation of a voltage. Figure 1 shows a typical thermocouple. Named after the German physicist Thomas Johann Seebeck, Seebeck effect is a phenomena which occurs when two dissimilar metals are combined to form a junction, with the two ends of the junction being maintained at different temperatures to generate an electromotive force resulting in a voltage. Figure 2 shows the pictorial representation of the Seebeck effect. Thermocouples are categorized into three main categories: nickel alloy thermocouples, platinum rhodium alloy thermocouples, and tungsten rhenium alloy thermocouples. The thermocouple types K, J, E, M, N and T are classified as nickel alloy thermocouples. Types B, R and S are classified as platinum rhodium alloy thermocouples. Types C, D and G are classified under tungsten rhenium alloy thermocouples. Any other type of thermocouples which one come across is either a noble metal thermocouple or a different form of the aforementioned thermocouples. A resistance temperature detector or RTD is a resistance thermometer which detects the correlation between the resistance of an element and the corresponding temperature. It is a length of fine coiled wire wrapped around a ceramic or glass core. An RTD can be of wire type or film type. Figure 3 shows a typical wire type and film type RTD element along with their parts. Thermistors are basically resistors which are thermally sensitive. Their resistance is dependent on temperature. Their primary applications include current limiters, temperature sensors, overcurrent protectors, and self-regulating heating elements. Thermistors can be classified into two types: negative temperature coefficient, also known as NTC, and positive temperature coefficient, also known as PTC. Figure 4 shows the experimental setup for the calibration of a thermocouple. The setup consists of a water heater indicator, a thermostat, a water heater control switch, a thermostat wire, a water bath, 4 locking screws to close the water bath, water drain out wall, K-type and J-type thermocouple, an RTD element, a thermistor, a thermometer, an equipment mode control switch, a thermistor, RTD mode control switch, a power source and a digital console to show the voltage or resistance reading. The apparatus required for carrying out this experiment are the thermocouple, RTD and thermistor which are being calibrated, a standard thermometer, a thermocouple calibration setup. Here goes the procedure for carrying out the experiment. Initially, fill the water bath with water and switch on the heater. Switch on the digital console of the equipment. Switch the equipment to thermocouple mode by operating the equipment mode switch. Immerse the K-type thermocouple in the water bath through the inlets on the bath lid and connect it to the power source as shown in figure 5. At room temperature, the console is set such that it reads 0 millivolt. As the water starts getting heated, the digital console starts displaying a voltage reading. As the water continues to boil, its temperature rises gradually and the voltage generated at that corresponding temperature is displayed on the console. Note down the temperature reading from the thermometer and observe the corresponding voltage reading from the console. For example, in figure 6, we can see that at a temperature of 33 degrees Celsius, the voltmeter reads 0.14 millivolts. Tabulate the temperature voltage combination readings for at least 5 values. Use the standard formula for calculating the actual temperature values for the obtained voltage readings for a K-type thermocouple. Find the difference between the calculated actual temperature and the measured temperature obtained from the thermometer to obtain the percentage of error in the K-type thermocouple. Disconnect the K-type thermocouple from the equipment and connect the J-type thermocouple and continue heating the water. Repeat the steps 7 to 10 and calculate the error in the J-type thermocouple. Next, disconnect the J-type thermocouple and turn the equipment control switch to RTD or thermistor mode. Turn the RTD or thermistor mode control switch to RTD mode. Connect the RTD plug to the power source of the equipment while the RTD itself is immersed in the water bath as the water bath continues to be subjected to heating. The console will now turn into a resistance meter and starts displaying the resistance value of the RTD in terms of ohms. Now repeat the steps 7 to 10 and compute the error in RTD. Next, disconnect the RTD and turn the RTD or thermistor control switch to thermistor mode. Connect the thermistor plug to the power source while the thermistor is immersed in the water bath which continues to be heated. The console will now display the resistance values of the thermistor in terms of ohms. In order to compensate for the decimal setting of the console, the values being displayed have to be multiplied by 1000. Repeat the steps 7 to 10 and compute the error in the thermistor. Finally, disconnect the thermistor and switch off the power being supplied to the equipment. The tabular column needs to be drawn as shown for a K-type thermocouple. It has to be noted that 4 separate tabular columns need to be drawn, one each for K-type thermocouple, J-type thermocouple, RTD and thermistor. The tabular column for J-type thermocouple is the same as the one drawn for K-type thermocouple. For RTD and thermistor, the voltage reading in the tabular column is to be replaced with resistance readings. Carry out the calculations using the standard formulae and find the percentage error in the K-type and J-type thermocouple. Similarly, use the standard formula for RTD to calculate the error in the RTD. And likewise, use the standard formula for thermistor to calculate the error in the thermistor. In this experiment, we need to plot two graphs, each for K-type, J-type thermocouples, RTD and thermistor. The first graph to be plotted for the thermocouples is a bar chart or histogram depicting the actual and measured values of the temperature against the measured voltage. For the RTD and thermistor, the histogram to be plotted is the actual and measured values of resistance against the measured temperature. The second graph is a line graph depicting the actual temperature versus error percentage for the thermocouples and actual resistance versus error percentage for RTD and thermistor. The limitations observed in this experiment are: it is not possible to ensure the accuracy of the thermometer reading as we are not calibrating it. Since the digital console acts as a voltmeter as well as a resistance meter, it is bound to carry some inherent error in it. While calibrating the thermistor, the resistance values displayed in the console keep changing continuously, resulting in unstable values. This concludes the experiment calibration of a thermocouple using a standard thermometer.
Hello students, today we are going to conduct an experiment calibration of thermocouple. The aim of this experiment is to calibrate thermocouples, resistance temperature detectors which are also known as RTDs, and thermistors using a standard thermometer. The apparatus for this experiment is a thermocouple calibration setup. The first step in this experiment is to fill the bath with water. You can see that the bath consists of a coil inside which is used for heating the water. The setup consists of a water bath, a J-type thermocouple, a K-type thermocouple, a thermistor, an RTD which is also a resistance temperature detector, a thermometer, a set of switches which need to be operated according to the experiment requirement, a control panel to display the voltage, a switch to connect the thermocouples, and a thermostat to cut off the temperature to the maximum possible value. It consists of an outlet valve to drain out the water after conducting the experiment. Before starting the experiment, it is important to know what is a thermocouple. A thermocouple is a temperature measuring device which records the temperature of high range temperature applications. It uses a principle called Seebeck effect. Seebeck effect is a principle which states that when two dissimilar metals are joined together to form a junction and the two junctions are maintained at two different temperatures, an EMF is induced resulting in voltage. In this experiment, we will be reading the corresponding voltages for the corresponding temperatures which are recorded by the thermometer. Now, let us start the experiment. Firstly, switch on the console. As soon as the console is switched on, you can see a reading on the digital display. This reading is nothing but the voltage reading. Next, turn on the heater, which is indicated by the red light that the heater is on. set the thermostat to 100 degrees centigrade so that the heater automatically gets switched on when the temperature of the water inside the bath reaches 100 degrees centigrade. Now we will connect the K-type thermocouple to the setup using this plug. The plug has to be connected in this direction only in the first two slots of the switch which has been provided. Once the K-type thermocouple has been connected to the setup, note down the voltage which is being shown in the digital display to the corresponding temperature being recorded by the thermometer. Similarly, note down 4 to 5 readings of different combinations of temperature and voltage. Now calculate the theoretical values of the temperature and voltage combinations using a standard formula for K-type thermocouple. Next, we are going to calibrate J-type thermocouple. Remove the K-type thermocouple and now connect the J-type thermocouple. Now take down the values for temperature of J-type thermocouple with its corresponding voltage. Now calculate the theoretical possible temperature and voltage combinations using the standard formula for J-type thermocouple. It is important to note that in this particular experiment, the voltage being displayed in the digital screen is in terms of millivolts. Now we have completed the calibration of K-type and J-type thermocouples. Next, we will be calibrating resistance temperature detectors, which are also known as RTDs. This is the RTD. Before we connect the RTD, we have to ensure that the J-type thermocouple is disconnected and the setup mode is changed to RTD or thermistor mode. Once you have brought this to RTD or thermistor mode, it is important to bring it to completely RTD mode by bringing this switch down. Now connect the RTD switch similarly as connected J-type and K-type thermocouple. Now note down the values for the corresponding temperature and the digital reading. It is important to note that when you have connected either an RTD or a thermistor, the digital display reading changes to resistance being measured instead of voltage. The resistance being displayed in the digital display is in form of ohms. For an RTD, always multiply the value being shown in the digital display by 10. Similarly, note down 4 to 5 different combinations of temperature and resistance. Now, using the standard formula for RTD, calculate the theoretical possible values of temperature and resistance combinations. Finally, we will be calibrating the thermistor. Before calibrating the thermistor, we need to disconnect the RTD from the setup. Change the mode from RTD to thermistor. And connect the thermistor to the setup in a similar way as to how the thermocouples and the RTD were connected. Note down the values of temperature and the corresponding resistance being shown in the digital display. It is important to note that for a thermistor, you have to multiply the reading being shown in the digital display by 1000. Similarly, take 4 to 5 different combinations of temperature and resistance for the thermistor. Calculate the standard values of temperature and resistance combination for a thermistor using the standard formula and carry out the calibration process. This concludes the experiment calibration of a thermocouple.
At MSR UAS, we spark your imagination unlike any other.